this is Russ Anderson. In this tutorial, I'm going to show a technique for solving long shots by breaking them into pieces. This works for 360 VR shots and for regular non-360 VR shots. Here we're going to use this 360 VR shot, which has around 34,000 frames to it. And we have opened this shot previously on this computer, so an index file is available, which lets it be opened up quickly. Without that index file, it would take a bit longer, as Synthesize has to go through and find all the frames in it and generate that index file. Once it's open, we can go and change the end frame value to 2000, and that's going to be the size of the piece that we're working on. So here we've got the first 2000 frames of the shot, and now we'll go and make whatever adjustments that we want to make for the processing of it. And we'll do that now so that we don't have to do it for each individual file. And we'll increase the number of trackers per frame because it's a 360 VR shot. You also want to go and set the file name, and the file name should have a number. Here we go with piece 1, and we're going to get piece 2, piece 3, and so on in due time. Similarly, we're going to do an initial export, and this is a camera and object path export. We just use the default settings, most importantly this entire shot one. So that export saves just the camera path as a text file. And we did it now just so that we have that initial value, that file name set up, and that's going to be replicated and adjusted for each of the individual sections subsequently. So once we've got everything set up in this first piece, now we can start making additional pieces. And to do that, we're going to use some scripts. They're out in the 360 VR area, although, like I said, it's not really applicable necessarily to 360 VR. I'll create next piece, and there's an intro version and a pro version. And the pro version is in Python. It uses the Python interpreter from your operating system, which you might need to install if you're on Windows. There's a Cynthia version of it for the intro folks. That does not have the capability to update the export file name automatically, so you'd have to do that manually if you're just using the intro version. We'll just run the pro version, and you'll see that the timeline is now changed so that it runs from 1800 frames all the way out here to 4000. Now the 200 frames here at the beginning is an overlap, and that overlap is used to set the scaling between successive pieces of the shot. When you're first setting up each of these pieces, you need to go and take a look at the end of the piece to make sure that the camera is actually moving and translating during that section. Here you can see I'm just walking along, so that's good. If the camera is just standing still and looking around in different directions and not moving very much, then we won't be able to do the splicing between the sections very accurately. In that case, you want to change that end frame value to be either earlier in the shot or a bit later, so that the section that's going to be the overlap with the next section, corresponds to a part where the camera is actually moving. And you just go and you work your way through the shot here, creating all these individual pieces, and it's updating the file names, as you see, as well as the export file name, at least in the pro version. So let's talk about what we're going to do for each of these sections. Once we've run through the entire shot and created pieces for each section, obviously the last section is going to be a little shorter. For each of these different sections, we want to run through the same process. And that's going to start out with running the auto tracker. And right after that, most likely you're going to want to clear all the blips subsequently just to cut down the file size, because you can wind up having quite a few files. Here in this shot, you wind up with 17 different sections, so you want to keep those individual files smaller if you can. Let's go take a look at one of the already tracked sections. And at this stage, you want to be going through and identifying and removing trackers that are not usable, not helpful. And you use that using the tracker delete mode. And with that turned on, you can just click on trackers and away they go. I'll point out, if you do a Control A, you can now change all the trackers to some other color if that makes it easier to see them. But you notice that if you use something that's too red, you wind up with something that's a little hard to tell if it's selected or not. But at any rate, you can just start using the different keys. The ASDF keys are set up for scrubbing through the shot and moving to the beginning and end. So standing on the D key steps through the shot. So the technique that I use myself for working with these shots is just to stand on the D key and wait for something that I didn't like, and then just stop and delete it, and then to continue pushing the D key. I found it helpful to do that cleanup process in 4 different stages. So the first stage was to go and just look at the cameraman here and look for any trackers that showed up there. And, depending on what section of the shot it is, later in the shot, here it's still out in front of me there. Later on, when it's up in the air, then there's less exposure and fewer trackers that are going to be on me. So the one pass is to identify and eliminate the trackers on the cameraman, and you also want to take them off of the shadow, so you can get trackers that are on the shadow as well. There are also some lens flares that move around from time to time. Here you see a tracker on a lens flare, so you want to get rid of that. And this is a Ricoh Theta S camera. It's got 2 different lenses. Here's another little lens flare marked down there. You can get 2 completely different sets of lens flares, one for each camera, depending on where the sun is in relationship to the lenses. So you can take a look through the shot for that. And finally, it's shots in the sky here really aren't helpful, and they tend to have very low accuracy, and it's best just to delete them all. And here there's a bunch of blue sky, so there are a bunch of trackers up there. Later in this particular shot, there are trees overhead, so very little of the sky is available or visible. So I found it most helpful in this particular shot to do 4 different passes through the shot at any given point in time, just focusing on one particular area. Depending on what your particular shot is, you might want to do something similar. It just depends on what you have in the shot. And of course, if your camera is mounted to a vehicle that's going to be sitting in some particular section of the shot, in the very beginning, and when you were creating the first piece, you might have wanted to do a roto mask to just wipe out that particular area. So what you want to do just depends on the particular shot that you have, and you can figure out what the right strategy is for it. Once you've got those trackers all cleaned up, then you do the solve to figure out where everything is in 3D. So I'm going to just hop over and open up an already solved section. So here you can see all the yellow X's that are from the different trackers. And I think in this particular shot, I went in the reverse order of actually first solving the shot and then getting rid of the trackers after that. But here, as you saw, I'm suggesting it's better to eliminate the bad trackers first and then solve, just because it does take longer when there are bad trackers present to get that solve, and you then have to go and eliminate them. So if you have to do the elimination part anyway, probably better just to do it in the first place and get the quicker solve. And once you do have the solve done, then the graph editor is the tool for helping find problems. Here you can see I didn't do a super great cleanup job, so you can go and find some trackers that are problematic that should probably still be fixed. And here's one somewhere in the middle. Don't have our images yet, but you'll see that sometimes these trackers go and shift off to different parts of the scene, and that gives you a complicated error curve like that. And the glitch fixing tool gives you a bunch of ways to fix that. And sometimes you might just be going and taking some spot and doing a shift click to split it into two separate trackers, each of which is now relatively decent. That maybe wasn't quite the right spot, but you can go through and clean these things up. And of course, it's a trade-off of how much time you want to spend in doing the cleanup and how much difference that's making to your final product. And that's a cost-benefit sort of trade-off there for you to make. So as you do this cleanup, then you're going and switching the solve to refine mode and just continuing to refine the solution until you get something that's acceptable, that you're happy with. And then you just run the export. You can do Shift X to do that, or you can do the export again to do that, since the file name has already been set up during the earlier stage. So after you've done all of those different sections, you have a whole collection of those text files that have camera paths in them. And now we can go and open up the original shot at its full length. And we're going to run a script that's import overlapping paths, which is what we created. And we're just going to select the first of those paths and have it process that. And the result is the entire camera path. At this point, now you want to do a coordinate system setup, and for a shot like this that has a big long camera path, the thing to do is to use the path-based method to do that. It's the subject of some other tutorials. Well, what we'll do is just rotate the scene around until we get an orientation that we like. And if you recall, the northward facing direction is straight ahead, basically. So we want to get this set up so that at the beginning of the shot, the camera is going to be looking straight ahead up towards the top along this initial section of the path, roughly, so that the user, when the user first starts playing the movie, they're going to be looking more or less in the direction of travel. So we just rotated the scene around to do that. And similarly, we've gone and adjusted it in the other views so that it's more or less level. You notice there's a little slope there, which corresponds to what happened out in the real world. once you're happy with this camera path, now you're ready to run the stabilize from camera path script, which is going to figure out exactly what that camera is that you wanted, that's facing the entire length of time straight ahead, perfectly flat and level, and exactly what it takes to do to the images to make that camera, the camera that you want, the reality. So we'll just let this run for a little bit. So that took about 3.5 minutes. And now down below, the software is starting to work its way through computing the stabilized version of the frames. Now we could do a save sequence out of Synthise and do everything inside of Synthise. But more typically what we're going to do at this stage is use one of the exports for the 360 VR stabilization. So unfortunately part of this is off the top, but you've got the After Effects a couple different ways, or HitFilm, and probably some other ones in the near future. So you just export the stabilization data, and then in your compositing application it'll actually be doing the twisting part of the stabilization. So you can do that as part of, color grading, adding other effects into the footage and whatever, and only have to do that one image resampling and one final copy of the images. So that would be your typical approach at this point. Let's make this stop now and just show, here's the sort of thing that you can get from this. This is a result off of that 10th piece that I had earlier, where the camera actually winds up going off the edge of this platform and so on. And you see the effect of the translation of the bouncing up and down in my steps as I walk, but everything is still very stable even as that is happening. The effects that you do see at this point are things that are due to any asynchrony in the cameras, which isn't an issue with the Ricoh one, but also with rolling shutter, which is an issue. So when you have rolling shutter present, that can create residual effects that you'll see even though the shot is stabilized. And if you look at it carefully, you'll see that some parts of the image are stable and other parts are shifting around a little bit due to the rolling shutter. But the overall effect still is something that is very watchable and not going to be introducing nausea like the raw footage from this can. Just a couple comments on the results also, that here the camera, the Ricoh Theta S, it has built-in inertial stabilization. The final results wind up not being all that super stable. That's just the nature of what you can achieve as a live effect based on that kind of accelerometer data. Here you're doing something that's based on the images that are produced, and you can stabilize them very, very well. It's still a good idea to have the stabilization in the camera to the extent that you can, and just in the rig that's holding it as well. And the reason for that is that if the camera is really, really unstable, then the images, unless you're storing raw footage, the images are going to have limited resolution due to limited appearance due to the bit rate issues, that everything's shifting around too much, so the compression isn't going to be as effective, and the image quality will suffer due to the original camera being not so stable. So, having some stability in the original camera is a good idea. In all cases, even though you're still going to be doing the stabilization to the final degree here. And I'll point out also that the other factor in that is motion blur, that you can have motion blur effects if the shutter time is too long and the camera is moving around too wildly. You'll see things appear to go out of focus a little bit when the camera is moving around a lot in real life, but in the stabilized result, it looks like everything is standing still, and then it just looks like for some reason the camera just went out of focus. So that's something to look out for and try and maintain the stability in your original camera, even though you're going to be doing the stabilization down the road anyway. And of course, in these final results, more resolution is always good, right? So a few final